Welcome to the lecture series. In this lecture series, we are going to discuss about the types of control systems and types of systems available. As we discussed about the basic elements of control system and basic terminologies in a control system. Now we are going to discuss about the types. Yes, there are different types of control system, starting basically from our open loop control system. Yes, we know, right? Open loop control system, we have a input, we have the process, and we have the output. No control feedback is taken for the, so no suggestions or feedback is taken for the control action. So this system do not uses the feedback, which means the output is not influenced by the actual performance of the system. Instead, the input of the system is predefined based on the set of predetermined values or rules or instructions. So this can make this open loop control system less precise and less responsible. Yes, it is less precise, less responsible, but we have to make a note that it is simpler in design and also it is reliable in nature. And next one is closed loop system. And yes, this closed loop system will take back the feedback, right? It takes the feedback from the output. It goes for the comparison operation, and it compares with the actual output. So the set point and the actual output is compared, and the difference is calculated, and this difference is called as the error. And the goal is to minimize this error, and thus it uses the negative feedback and positive feedback. According to the negative and positive feedback, either the input or the output can be boosted or reduced according to the error value optimization, and thus they make the closed loop system more precise and more responsible to the changes in the system, and thus it is little bit complex compared to our open loop. And apart from this open loop and closed loop, yes, we have a continuous control system. What is continuous control system is nothing but it operates over the continuous ranges of time, right? So continuous ranges of time is in the real world every signal is then continuous varies with the time, right? It's an analog signal, and thus continuous system applications where the continuous outputs required, such as temperature control system in a thermal plant that requires a continuous temperature monitoring, and the output also is to be maintained continuously. So in that real world system we will choose the continuous control system, and comes under the discrete control system. So we have continuous, obviously we will have the discrete. So discrete is nothing but discrete points in time. It operates in discrete point of times, so it does not have the continuous signal here. So the input and output are typically represented by the digital signals. Yes, so discrete signals are often used in the applications where the output is only at this specific time. So you can see machine control system. There is temperature control system, it's a continuous time. Here it's a machine control system. So whenever the machine gets failures or machine gets deviated, it can be used. Next one is linear control system. Yes, we have another type, that is linear control system, represented by linear differential equations. So these systems have a certain properties such as superpositions that can make them relatively easy to analyze and control. And next one is non-linear control system. So these cannot be represented by the linear differential equations. So that exhibits a behavior such as chores and drawbacks, and nonlinear can be more challenging to analyze and control their linear systems, and they require a specialized techniques and algorithms. And coming to the next one, time invariant control system. Yes, we have that, but the input output relationships maintains the same for all the times, so it doesn't have the time invariant with respect to the input, which means the system dynamics do not change over the time. So time invariant are often used in applications where that output or that thing are not expected to vary significantly over time. So next one is we have time varying also, and these are time varying inputs where the time vary between the input and output relationship because of the system dynamics or external factors, and they can be more challenging and control than, yes, it may be more challenging than the time invariant. And next we have the input, single input and single output. Yes, ASO control system. Yes. Here we can only have the single input and single output, which means there's one degree of freedom in the system, and it is simple to analyze and often used in the basic control systems. And next one is multiple input and multiple output. Yes, this is a little more complex because we have multiple inputs and outputs, and it is a little more complex in analyze. And they can be used in the control systems where we have multiple degrees of freedom and even achieve more advanced objectives. So in the next lecture series, we will discuss this time variant and invariant system in briefly. Thank you.